When it comes to space exploration, few moments are as intense as the entry, descent, and landing, EDL, on Mars. This is the phase NASA affectionately refers to as the 7 minutes of terror. Why? Because it takes just 7 minutes for a spacecraft to travel from the thin upper layers of Mars' atmosphere to the surface of the planet. During that time, the spacecraft must slow down from a breakneck speed of 12,000 miles per hour to a gentle stop, ready for a soft landing. One tiny miscalculation or malfunction, and the mission could end in disaster. Yet, year after year, NASA has managed to successfully navigate these harrowing 7 minutes, and each success has pushed humanity a step closer to answering one of the most profound questions: could Mars have once supported life? The fascination with Mars began in the early 1960s, when humans turned their attention to the red planet with wonder and, let's admit it, a bit of audacity. The allure of Mars, a world that had captivated scientists and dreamers alike for centuries, was undeniable. However, our attempts to explore this distant neighbor didn't exactly start smoothly. In 1960, the Soviet Union launched Marsnik 1, a spacecraft that was meant to reach Mars but never even made it out of Earth's orbit. It was a rough start, but not the end. The space race was heating up, and the quest to understand Mars was about to get serious. In 1964, NASA entered the race with the Mariner 4 mission. This was a game-changing move that succeeded in flying by Mars and sending back the first close-up images of the planet. Those grainy black and white photos, while underwhelming by today's standards, were revolutionary at the time. They showed Mars wasn't just a tiny red dot in the sky but a barren world covered in craters and dust, a stark, desolate landscape. The real leap in our exploration of Mars came in the 1970s, with NASA's Viking program. Viking 1 and Viking 2 were the first successful landers to touch down on the Martian surface, sending back color images and conducting experiments to search for life. While they didn't find little green Martians, the data they collected hinted at something extraordinary: Mars had once had water. It was a tantalizing clue that suggested the red planet might have been far more hospitable billions of years ago. After the Viking missions, there was a bit of a lull in Mars exploration. However, the 1990s saw a resurgence in our desire to explore the red planet. And this time, NASA had a new approach in mind: rovers. While orbiters had given us distant views and stationary landers provided close-ups from one spot, NASA realized it needed a way to truly explore Mars. In 1997, NASA made history with the launch of Sojourner, the first ever Mars rover. It wasn't much larger than a microwave and wasn't exactly fast, but it was groundbreaking. Sojourner roamed the Martian surface, analyzed rocks, and sent back the first close-up images of Mars. This was the moment when the idea of sending robots to move around on Mars, explore its vast terrain, and return valuable data became a reality. This pioneering mission set the stage for future Mars rovers. In 2004, NASA launched not one but two rovers, Spirit and Opportunity. These twins were tasked with exploring opposite sides of the planet, and they far exceeded expectations. Spirit lasted 6 years, and Opportunity, get this, survived for an astonishing 15 years. These rovers found evidence that Mars had once been much wetter, discovering minerals that form only in the presence of water. Opportunity even made a jaw-dropping find: small, round rocks that scientists nicknamed blueberries, which provided clear evidence that liquid water had once flowed across Mars. After Spirit and Opportunity, NASA's ambitions grew even larger. In 2012, NASA launched Curiosity, the largest rover ever sent to Mars, about the size of an SUV. Curiosity was equipped with an advanced suite of scientific tools designed to go beyond the search for water. It was on a mission to uncover signs that Mars might have supported life. Curiosity landed in Gale Crater, a site scientists thought might contain key clues about Mars' past, including evidence of ancient lakes and streams. Within a short time, Curiosity made a groundbreaking discovery: organic molecules in the Martian soil. These molecules are the building blocks of life, suggesting that Mars could have had the right conditions for microbial life billions of years ago. Curiosity's findings showed that Mars wasn't always the frozen desert we know today. It might have once been warm and wet enough to host life. The rover also uncovered evidence that Mars' environment changed over time, from a wet, potentially habitable world to the cold, dry planet we see now. This discovery fundamentally altered our understanding of Mars and raised new questions about whether life could have existed on the red planet. But NASA wasn't done. After the success of Curiosity, NASA knew it had to push the envelope further. Enter Perseverance, the most advanced Mars rover ever built. Launched in July 2020, Perseverance was equipped with cutting-edge technology designed not only to search for signs of ancient life but also to lay the groundwork for future human exploration of Mars. Perseverance's primary mission was to search for biosignatures, traces of ancient life, by studying the geology of Mars, specifically in Jezero crater, which scientists believe once held a lake. The rover is also collecting rock and soil samples that will eventually be returned to Earth for detailed analysis, providing an unprecedented opportunity to study Mars' past. These samples could offer vital clues about the planet's history and its potential for life. But Perseverance's mission wasn't just about exploring the past, it was also about preparing for the future. One of its most ambitious experiments involves a device called MOXIE, Mars Oxygen In Situ Resource Utilization Experiment, which is testing whether it's possible to extract oxygen from Mars' thin atmosphere, which is mostly carbon dioxide. If MOXIE works, future astronauts could breathe on Mars by producing their own oxygen from the Martian air. This is a potential game-changer for long-term human missions to Mars. Perseverance also has a unique companion, a small helicopter called Ingenuity. While Ingenuity isn't part of Perseverance's main mission, it has proven to be a technological marvel. It became the first aircraft to fly on another planet, demonstrating that powered flight is possible on Mars. Ingenuity is helping Perseverance explore areas that would otherwise be difficult or impossible to reach, adding a whole new dimension to the exploration of Mars. Building Perseverance was no easy task. NASA had to engineer a rover capable of surviving the harsh Martian environment, extreme cold, fierce dust storms, and intense radiation. The rover's design was tailored to withstand these challenges. Its wheels were specially made to handle the rocky, uneven terrain of Mars, while its body was built to endure the freezing temperatures and cosmic radiation of the planet. One of the standout features of Perseverance is its incredible suite of scientific instruments. From its SuperCam laser, which can analyze rocks from afar, to Sherlock, a tool designed to detect organic compounds, Perseverance is a scientist's dream come true. Its drill extracts samples of Martian rock, storing them in special tubes that could one day make their way back to Earth for analysis. Perseverance is not just a rover, it's a science laboratory on wheels, a cutting-edge explorer that has already started to rewrite the story of Mars. And its work is just beginning. Landing on Mars is always a risky endeavor. In February 2021, Perseverance entered Mars' atmosphere at a speed of 12,000 miles per hour. In just 7 minutes, the rover had to slow down, deploy a parachute, and gently land on the surface, all without making a single mistake. NASA engineers call this period the 7 minutes of terror, and for good reason. If anything went wrong, the mission would have ended in failure. But it worked. Perseverance landed safely in Jezero crater, one of the most promising locations for finding signs of ancient life. And with that, the next phase of Mars exploration had begun. NASA's Mars exploration program has come a long way, from early spacecraft that barely made it out of Earth's orbit to advanced rovers that can explore the Martian surface. And as we look to the future, the question isn't just whether we will visit Mars, but when we will live there. With each new mission, we get closer to the possibility of sending humans to Mars, where we will explore, understand, and eventually, maybe even call home. And with each discovery, we unlock a little more of the mystery of Mars, its past, its potential, and the role it may play in humanity's future. Mars is no longer a distant dream, it's a tangible goal, one that we are on the verge of achieving. The journey to Mars has been one of innovation, determination, and vision. As we continue to send more missions to the Red Planet, we inch closer to understanding its secrets and preparing for the next giant leap in human exploration. NASA's Mars program is a testament to the power of science, technology, and